Hey guys, our 5-year mission to explore the wild universe of linear equations is pretty much drawn to a close. Our 26-page slideshow has been reduced to two. However, don't celebrate too much. Today's going to be a longish lesson. So without further ado, we're going to look at what's called a linear system. And what it is two or more systems, two or more equations being looked at the same time. Now, we're only going to look at two, but the proper definition is two or more. Now, in the real world, this is done to compare. Done to compare and find out what's a better deal. And this is done by finding where the points meet. Sorry, where the lines meet. Hopefully, my microphone isn't good enough that you can hear my son being an idiot upstairs. Okay. So there's three possible outcomes. Uh, so the first one is lines are parallel. Zero solutions. Second one, lines cross. One solution. And the third one, and this is the hard one to visualize, the lines are on top of one another, in which case there's infinite solutions. Now, as I recall, there are no, these other two scenarios don't come up in the homework, but don't hold into that. There might be one or two questions that have these situations. For the most part, we're going to be dealing with this middle thing. So here we're being asked to solve. Don't know how to graph this. We could either do y equals mx plus b to graph, or we could do the intercepts. I'm going to convert it into y equals mx plus b, which is going to allow us to graph it fairly easily. So it's minus 3, and where are we? Oh, better make sure yours didn't change. It didn't. Okay. Up 1 over 2, up 1 over 2. Okay. And again, my habit is to draw dots all the way across the page just because it takes seconds to do. Oops, that should be an X. Again, as always, I will fix it up and make it look pretty later. 3, 4, 5, 6. So that's going down. down 1 over 1, down 1 over 1, down 1 over 1. My habit is I circle the one where they meet. Hopefully your lines are better than mine. I've been doing so good. Finally, this is like our therefore statement. And we're literally just reading it off the graph. We can do a check. You won't have to do this for every one, but just to remind you, because sometimes it's going to ask you to. Notice I'm doing this backwards to the other. Um, and I want you to notice, have to check both equations. The reason why is that it might work in one and not the other. It means you made a mistake. Now, I'll be honest, with a graph, it's not going to come up very often. Grade 10, one of the first things you're going to do is you're going to learn how to solve these algebraically, and it is very possible to make a mistake and have it work in one and not the other. So it's a good habit to get into this year so that next year everything is wonderful. Okay. Couple has budgeted $5,000 for the wedding reception. Which hotel offers the better deal and under what conditions? So we don't know. We've actually just been given a whole bunch of information. So for Waverly, the cost is $40 per guest plus $200 just to get in. At Hotel Niagara, the cost is $30 per guest plus $1,000 to get in. C equals cost in dinero. G equals guests in the room. So we have our equations. We got I was nice this time, gave you guys a sheet. So it should be over 1 up 40. I don't have an over 1. So I am going to pick a value. So over 100 is up. 40 times 100 is 4,200. So that's going to be there. My line missed. And 1,000 plus 3,000. Oh, is that my point of intersection? $3,000 plus 1,000. No. Cool. I messed them both up. Next year when we learn the algebra, you guys are going to hate me for it, and the whole reason that we learn the algebra is so that you don't screw up your graphs. Graphs are really easy to make a mistake with, and they just simply don't work. Okay, or they're not accurate enough, not when they're being drawn by hand. Now with computers, you can do an awful lot of it, but you got to be more accurate than I am. Again, I am hampered by the technology that I have. If I had a pen and paper, it'd be a lot easier to mark up to match my points using a ruler. So my point of intersection is where the lines meet. So according to what I've done, what is that, 90? I'm going to be lazy, you can call it 85. Not quite accurate. What is that, 3,400? Which actually isn't too far off what the proper answer is supposed to be. I'm a little off. It should be 80 and 3,400, but I'm going to follow what my graph shows, and we'll go from there. So the thing is, I can't extend this. Cool. There we go. They're the same price at 85 gas because that's where the lines meet. And so the reason that we bring this up is that if I were to say which one is cheaper, you couldn't give me one answer. You couldn't say that Niagara is cheaper all the way through because it's not. Niagara is only cheaper providing you have less than 85 guests or providing you're less than $3,400. Hotel Waverly is the better one over 85 guests. So it really depends on where you want to be in order to make that purchase. Not where you want to be, how many guests you want to invite, or in this case, how much money they have to spend. So since they have $5,000, what is that? Oh, sorry. I should be a good little boy and write stuff out. So that's H, and that's Waverly. So it means that Hotel Niagara, I don't know why I can't extend it from that other screen. It is Hotel Niagara. So Hotel Niagara is the better option at $5,000 because they can get more people in, right? If this chart extended that little bit farther, right around here would be $5,000. Well, Waverly Place is up high on the cost index, and this one's lower. It actually takes longer to hit the $5,000 mark. So this one, the graphing is easy. We've done all the graphing before. We've manipulated our formulas before. We know how to do all that. It's the interpretation of the results that's the focus of this section. Okay? Again, if you need my help, I am a text away, I am a email away, and we can set up a video chat. This time I will say good luck, guys, and mean it.